Of all the planets in the solar system, Mars captures the human imagination more strongly than any other.
It is not as unreachable as the distant gas giants, and not as merciless as the scorching planet Venus.
It is often called a neighboring world, almost the second stage in humanity's cosmic history.
And for many decades now, the question of sending humans to Mars has sounded not like pure science fiction, but like a real task for the future.
But what does it truly mean to send people to another planet?
It is not simply a longer spaceflight.
It is a step into an entirely different scale of complexity.
A flight to the moon takes days.
A journey to Mars would take months.
That means the crew would have to live in a confined space for a very long time, far from any quick help from Earth, exposed to radiation, limited supplies, and constant psychological pressure.
Let us imagine the moment of launch.
A giant rocket rises from Earth, and inside it are several people who understand that what lies ahead is not an orbital flight, not a short expedition, but a journey between worlds.
Earth begins to drift away.
At first, it still seems like a familiar home. Then it becomes a bright planet against the darkness. And with time, it turns into nothing more than one especially bright star among others. On the way to Mars, one of the main dangers would be cosmic radiation. In low Earth orbit, astronauts are still partly protected by Earth's magnetic field. But in interplanetary space, that protection disappears. High-energy particles coming from the Sun and from deep space can be dangerous to the human body. That is why a future spacecraft would need strong shielding, and the mission itself would have to account for periods of solar activity and provide emergency shelters inside the ship.
There is another challenge as well: weightlessness.
Long periods in microgravity weaken muscles, affect bones, circulation, and coordination.
Astronauts would have to exercise every day just to stay in shape.
In a sense, a flight to Mars would not only be a journey, but also a constant struggle to keep the human body functioning in conditions for which it was never designed by nature.
But the technical difficulties are not the only ones. There is also the psychological side. Mars is far away.
A signal between Earth and Mars does not travel instantly, but with a delay of several minutes, and sometimes even longer.
That means there would be no
conversations with Earth would turn into a slow exchange of messages. The crew would find themselves in a situation where many decisions would have to be made on their own. It would no longer be an expedition under constant control from Mission Command, but a much more autonomous form of existence.
When the spacecraft approaches Mars, a new phase begins: landing. It is considered one of the most difficult tasks of all.
Mars has an atmosphere, but it is too thin to slow a spacecraft comfortably as on Earth, and too thick to be ignored completely as on the Moon.
That is why entry, descent, and landing require extremely precise calculations.
It is no accident that engineers sometimes call this stage the 7 minutes of terror, even for robotic missions. If humans do land safely on the surface of Mars, they would see a landscape that humanity so far knows only from images and data sent by robots. Reddish dust, rocky plains, cold dry air, a pale sky, traces of ancient riverbeds, and perhaps the distant slopes of giant volcanoes. A day on Mars is almost as long as a day on Earth, but the world itself would feel alien. Gravity is weaker there, the atmosphere cannot be breathed, temperatures are low, and dust could become a constant problem for equipment in spacesuits.
The first humans on Mars won't just be walking on the surface and waving a flag.
They'll have to live, work, gather resources, build temporary structures, and carefully conserve air, water, and electricity. One of the main goals will be to test the potential for local resource utilization, such as extracting water from ice or producing oxygen and fuel from the Martian atmosphere. Without that, a long-term human presence on Mars would be extremely difficult.
But why go to Mars at all? The answer can't be boiled down to a single point.
It's about science, studying the history of a planet that may have once had rivers, lakes, and a warmer climate.
It's about searching for ancient microbial life.
It's about technology, developing systems that could one day be built for even more distant planets. And finally, it is a symbolic step. Humanity would become a species of not one world, but at least two.
Mars matters for another reason as well. It is both a warning and a hope. On one hand, it shows how a planet can lose most of its atmosphere and become cold and dry.
On the other, it remains close enough and understandable enough to be seriously considered as a destination for future expeditions. One can imagine the first human standing on the Martian surface, looking up and seeing in the sky a small bluish point Earth. In that moment, all of human history would seem far away, compressed into a single shining spark. And at the same time, that person would understand, this spark is no longer our only address in the universe. The first journey to Mars, if it happens, will not be just a technical achievement. It will become an event that changes humanity's sense of itself. For the first time, people will truly cross interplanetary space as passengers of their own future. And many years later, this flight will go down in history as the beginning of a new era, when space ceased to be just an object of observation and became a place where humanity truly reached new heights.